Hi students, if you're watching this video, it probably means you've already watched the basic 5 reaction videos prior to this. But I wanted to make a special video for one particular topic. It's raised in books and sometimes it's kind of categorized as a separate type of reaction, which is referred to as the formation of a gas or a gas evolution reaction. So here we go. So gas evolution reactions. In a lot of books, you'll see this table. And what they show is they show the production of a gas. So in all of these reactions, you see that a gas is being produced, okay? In the first type, the sulfides, we see that the gas that's produced is hydrogen sulfide. And if I look at this, it's very easy to categorize this as a double displacement because we see, like we did in the double displacement reactions, we have two compounds and they switch partners, remember the do-si-do, and result in two new compounds. So we can take a look at this and see, oh, well, the sulfide switches with the chloride, producing the hydrogen sulfide gas and the copper or the potassium chloride. With the other ones in this table, it's not as clear. It kind of looks like a double displacement, but there's not two compounds, so people get really confused. So I kind of give this a weird little name. I call this basically a double displacement coupled with a decomposition. And what I mean is you're still going to do from your two compounds, you're going to do that do-si-do, predict your products, and look at the two compounds produced. However, if you form one of these unstable intermediates, you have to recognize it breaks down right away to a gas. So carbonic acids, or we talked about this in the decomposition, carbonates break down to CO2. If you produce in a double displacement the sulfite or a bisulfite, you notice you produce SO2. If you produce ammonium hydroxide, it's an unstable intermediate, and you end up producing ammonia. But when you look at all those gases that are being produced from these unstable intermediates, what they all have in common on top of being a gas is the other component that breaks down results in water. And that's because if you look, H2O CO3, if I subtract the CO2, what's left in this formula? Water. It's the same with the H2SO3. Subtract SO2. What's left? Water. That's what they all have in common. Now, the ammonium hydroxide, it's harder to kind of see it. So I tell people we're going to subtract NH3. And what's going to be left is HOH, which we saw in our neutralization reactions, is just water because it's the proton from the acid and the hydroxide from the base. So here's another way to look at it. In a double displacement, we're going to do the do-si-do. If I form one of those unstable intermediates I just showed, it's going to be coupled with or followed by a decomposition. So if you form one of these unstable intermediates, that's what's going to happen. So let's start with the easier one, carbonic acid. If I form carbonic acid, I'm going to produce, it's going to break down in that double displacement and give me H2O and CO2. So when I look at this, that's exactly what happens. Now, how do I know that this was the unstable intermediate? They don't show me carbonic acid. Well, if you do the do-si-do like we've been doing, so let's assume everything breaks apart. Here I have my hydrogen ion or the proton, the chloride. I'm not going to worry about balancing. I'm just going to put my charges. There's my sodium. There's my carbonate. And when I do the do-si-do, their sodium has a plus charge, chloride has a -1, so what do I get? I get my sodium chloride. And it's aqueous because of those solubility rules we talked about. We're worried about balancing after we determine products. And now when I do the do-si-do and I switch partners here, what do I end up producing? Well, the CO3 2 minus, the carbonate, has a 2 negative. The proton has a +1. I do my crisscross applesauce, and what do I get? Carbonic acid. But it's an unstable intermediate. So the carbonic acid, once it's produced in this double displacement, it's no longer stable and it decomposes. So I get that. And where do I see that? Again, if I produce a sulfite or a bisulfite, like in the case of sulfurous acid or ammonium hydroxide. So I hope this video makes sense of how gas evolution reactions, they are kind of their own category, but we're still building on our existing knowledge of knowing it's basically a double displacement coupled or followed by an unstable intermediate in the double displacement, breaking down to water and a gas. So again, I hope that helps. And if you have any questions, please leave them. Thanks for watching.